Okay, any assignments I don't yet have up here in the front? And then an announcement. So right now we're at the full 70, which is the current class enrollment. There are 7 grad students on the wait list currently. Like I said, I'm still expecting the grad students who are on the wait list to get in, either by people dropping, or I will increase the enrollment a bit. I'm not yet sure for the undergrads and the concurrent enrollment students how that's going to shake out. But that's just sort of the current situation. Let's see. Okay, so questions about logistics or questions that came up from last time? Okay, so I'm going to continue with the examples that we were working on. So now you guys have seen and worked your way through the tutorial. So now you've sort of started to build up your working vocabulary of some of the commands that we can use and how we can combine commands to do various tasks. So we'll continue in that vein with the examples today. And I'll try and illustrate not only some of the commands, but also sort of, continuing on with how you combine them. What are some of the pitfalls that come up as you're trying to think about how to pass information from one place to another to get done what you want to do. So just ask questions as I'm working through these and as things come up that either relate to the material in the tutorial we're looking at or just other questions here. Okay, and again, these missions, as I titled them, were in some ways sort of motivated by just things that I happened to be doing, and was like, oh, I need to do this, and then I was like, oh, that would make for a decent example to try and work through some of the functionality. So here's the third one, which is, this happens to me all the time, is I'm working on a project, and I have in some R code file, I have the code to actually create a plot. And then I need to go back and recreate the plot, but I have no memory of which code file the plot was actually created in. So this is very common, at least for me. So that was sort of the motivation here of this particular example. Okay, so suppose we're in the units directory of the material from 2 years ago, where I have a much larger set of files, so it's easier to work with as an example. If I look and see what R code files there are in here, there's one file essentially for each of the units. So there are some 10 or 15 code files in here. Okay, so I could, for example, ask a question like, oh, I think I created this plot in a file that was one of the more recently accessed code files. So that's what I'm trying to do here, is the -t flag is going to sort things by the last time the file was accessed. So if I do ls -l, what we can see is there's information here on the time that the file was last accessed and the date. Now this is a little bit of a silly example, because all of these files were created when I cloned the GitHub repository rather than just when I was working with them over the course of months or years or whatever. So these are all the same. So it's not a great example in that respect. But in general, these dates and times would be different depending on when the file was last accessed. So if I do ls -tr, it's going to give me a list of the files that were accessed most recently. If I add an L in there, then it'll do it. Then it'll show me the date information. And so this should give me the most recently accessed at the bottom, and the ones that were accessed longest ago at the top. Okay, like I said, these are all the same time, but that would be what would happen if we had a directory that had files that were accessed, I shouldn't be saying accessed, files that were changed at different times. Okay, so suppose that I knew somehow that the file I'm looking for was amongst the last 5 files that were modified. Okay, so now I'm going to take the output of ls, and I'm going to pipe that output into tail so that I get the last 5 of the file names. So now I've got that, and now the idea is I'm going to just try and look in those 5 files for the particular name of the PDF that I think I might have created in the code in one of these files. Okay, so questions about the setup or motivation here? Okay, so if I then try and do this, right? So this would then be me looking for the character sequence PDF. But the problem is if I do it as a pipe like this, what's going to happen? It's actually just going to look it's going to look explicitly in the output of the tail command, which is this. So it's actually looking for PDF in this. It's not looking for PDF inside of the files. Okay? Because if we're piping things, then what's coming into grep is standard input, and that's going to be the output of this. So we're not treating those file names. We want to treat these file names basically as input arguments to grep. We don't want to treat those characters as the input to grep. So PDF doesn't occur in those 5 lines that I just printed to the screen. If instead I did, say, grep of optim, then indeed I'm able to find the word optim, or the sequence of characters optim, here, but that's being found in this sequence, in those 5 lines. Instead, I want to basically turn those 5 lines into a format such that the shell recognizes, well, actually, use the shell to turn those into a format so that grep recognizes those are files, names of files in which grep should be looking inside of for the pattern of interest. Okay, so you sort of have 2 options here. One of them is, we already saw the syntax of, you can create values to then insert in the middle of commands, where this would be some command in here, right? So we saw that. I think you guys would have seen that in the tutorial. So that if we do something like this, if we put a command or sequence of commands in here, then we can basically turn this into an argument that will be used as the argument to grep. in that format. So we could, for example, do something like this. So what I want to do is grep for, say, example.pdf in the files that result from doing this sequence of commands in here. Well, we know what this is going to create. This is going to create a variable, a Unix variable, and that variable is going to contain these 5 elements, which I want treated as the names of the files in which I want to then go look for example.pdf in this case. So this should do that. So let's try and see if that works. Okay, so it looks like I have not found example.pdf in there. So let's see here. So what if we look in all of the files? Okay, so there's a problem. So it's not actually in the last 5. It's in one of the other ones. Okay, so the example didn't quite all hold together. So let's just take the tail out of this and just do this with all of the code files here. Okay. So now if we do that, we can see that it does print out that indeed it found example.pdf in this particular file. So that's the one I need to go back to if I want to then be able to recreate that that PDF that I'm interested in recreating. Okay, questions, comments? Okay, so that would be one way, is to basically take the output and then treat it as an environment variable, and then this will basically become the input argument to the grep command. The other is this trick called Exurbs, which is basically saying, take the output here that's in the yellow. So take this output and then pipe it into this funny Exurbs command. And what Exurbs is basically doing is it's taking the output here and sort of flipping it around onto the end of the next command and treating it as the input argument to the next command. So, so we've got the flag here. Oh, sorry, I don't want the example.pdf there. Oh, wait. Oh, yeah. So right. So we've got grep, we've got the flag, we've got the pattern we want to look for, and then we need the argument that is the name of one or more files that we want to look into. And so Exurbs is basically taking the output from there, flipping it around so that it is passed in as the argument here at the end. And so if you're in the situation that you want whatever comes out of a previous command to then be used as an argument of the next command as opposed to being passed as standard input to the next command, then Exurbs is one way, is a standard way to do that. Okay, so what if I go ahead and do that? Oh, right, I don't want the tail for reasons that we just discussed. Okay, so that goes and then prints out the exact file that I'm looking for. Is there a question in the back, or are you just stretching?
I did a question. I was
Okay.
hesitant. The L flag in grep?
Right, so the L flag, so we notice that if we take the L flag off, we get both the file name and we get the string, the line in which it was found. So the -L is saying just return the file name if we're not actually interested in the actual text in which it was found. Okay. And that comes in handy lots of times if you're trying to find the file name as opposed to actually trying to find the line or the sequence that you're looking for. Okay, any other questions? Yes?
Why not use the grep-r flag?
Okay, so what does grep-r do?
It searches recursively within files for the string needed.
Okay, so let's see if we can find that in the help here. So I'm just hitting N to... okay, so recursively search in subdirectories. Yeah, so we could certainly have done that instead of passing the ls*r in there. In this case, I might not want to have it spend the time looking in a bunch of other files like binaries and things like that if I know that it's in the .r file. And I might not actually want to search recursively into subdirectories. Maybe I know that it's in this particular directory. So there are sort of various ways you could treat the problem, but that's a good thing to be aware of, is that you can search deeper into the subdirectory structure, which is what you were getting at. Yeah. Yeah, so that's great, and I do want people to chime in if they have another way of solving problems here. So just raise your hand and weigh in. Other comments, questions? Yes.
What if the no XARGS?
Oh, you don't have that on your machine?
I think.
Are you saying you can't use xargs because it's not on your machine?
Oh, I said if there is no that word, I think will it work?
If there's no what?
No XARGs.
Okay, so if you don't have access to xargs, maybe because you're, I don't know, running git bash or something like that, then you could still use this approach here. Is that not the... Huh?
Well, what will happen if we don't type XARGs?
Oh, what will happen if we don't type xargs? Thanks. So if I just do this, is that what you mean? Yeah, okay, so if I do that, then it's explicitly going to look for example.pdf, but it's going to look for it in whatever the output of the ls is, which is going to be something like that. So it's not actually looking inside the file. It's just looking in the list of file names. So that's not what we're trying to do, because ls, because this is just printing out the file names, and if we just pass this in as the standard input to the grep, well, example.pdf doesn't actually occur in any of these strings here, and so we're not going to find it. And in fact, that's not what we're trying to do here. Okay, so I think that's maybe all I want to say about this. Actually, for the sharp-eyed amongst you, there's actually a little bit of a bug in the code here. Anybody notice what that is? No? Okay, so actually, if you're passing in an expression to grep, it's actually going to be using regular expression syntax, which some of you might already know, or some of you might have looked a little bit more into the bash tutorial. And so period actually just stands for any character. So what I'm really searching for here is example, any character, and then PDF, which works in this case to find example.pdf. But strictly speaking, it's not searching exactly for example.pdf. And if I wanted to do that, I could escape the period and say, treat that period explicitly as an exact period when I'm searching for this particular string. In this case, it doesn't really matter for the purpose of a quick and dirty solution to the problem as I posed it, but there could be other cases where that might matter. So that still works there. Okay. Questions before I go on to the next one? Yeah, Jim.
Could you enforce the literal interpretation by using double quotes?
I don't think so. If we're talking about literal versus non-literal in this context, we could put, for example, a Unix environment variable in here, and that should then substitute in whatever the value of A is here into the pattern and then search for that resulting pattern if we use double quotes. So that would then substitute in the value of A and then use that as the pattern. If we use single quotes, it's going to explicitly search for example $, squiggly bracket A, squiggly bracket, character PDF. But there's probably a command to grep that says just search literally for the sequence of characters and don't use regular expressions. You could look at the help and see if that's feasible. Yes?
It's the F option.
F? Okay, so that probably stands for fixed. So if you were to do grep minus F, then it's going to search exactly for the particular character string. So in that case, I could do grep minus F. I could do grep minus F like that.
Capital F, sorry.
What's that? Oh, capital F. Okay, thanks. Okay, so that works. As you can see, I haven't memorized all these flags. I certainly don't expect you guys to. It's a matter of sort of you get to know some of the ones that are useful to you. You have a sense that many of these commands can do almost anything that you want them to do if you go look for the right thing, and then you go figure out what the flag is that you need. Okay, other questions or comments? Okay, great. So that was all good discussion of that one. All right, so let's look at the next one. Okay, so this next one is, suppose I've got a whole set of R code and Actually, something similar to this would work if you had a whole set of Python code in lots of different files as well. Suppose I have a whole set of R code files and they load various different R packages, but somebody gave me those code files and I haven't actually installed all of the packages I need to be able to run their code. So the idea is to sort of automate the processing so that I can basically install all of the R packages I need to run this whole set of multiple, all of this R code that's in multiple code files that somebody else sent to me. Okay, so let's go ahead and play around with trying to solve that problem here. Okay, so this is mission number 4. And I'm just cutting and pasting the code from the unit. Okay, so we're going to use so one way to think about this would be, suppose that, and this is again, this is more just to illustrate the use of some more of this, what's called file globbing. So this is not quite regular expressions, but it's related, which is, if I want to look in all of the files that end in .r, but that have unit 1, unit 2, unit 3, up through unit 9 in them, and then any sequence after that, this will then look for the word library in those code files. So if I just do ls like this, we can see what it returns. If I took out well, I can't really take out the star. Like, what if I just wanted unit 1 up through unit 9? I'd need to do something like, actually, I'd probably need to do this and then star, and that would exclude unit 10, unit 11, unit 12. But if I just have the star, then that's also going to match to unit 10, unit 11, et cetera, et cetera. In any event, this would allow us to sort of restrict down to just some of the files if I only wanted to look for the cases where a particular R package was loaded from some of the files. Doesn't really matter exactly which set of files we look in for the sake of illustration. Okay, so let's do this. Let's keep going here. So we're going to look for library, the instances of library in all of these code files. And it turns out that we found a bunch of them. Most of them are of the form that the line is just library and then the name of the R package. But other ones are a little more complicated. Like there's a library help equals. There's a case where I've got two. I'm loading 2 packages in a single line where the different commands are separated by a semicolon. A couple other examples in here, like this one here, doesn't actually load any packages. So you can see that the word library is used in a few different ways that we're going to need to try and process and deal with. The other thing is that it does show the names of the files here, and that's not something that we want that's not something we need to process. It's not something we need to know for the purpose of what we're doing here. So this ---- no file name should work to get rid of that. Actually, for those following along, is ---- no file name, does that work on a Mac? Just out of curiosity? Yes? Okay, great. I wasn't quite sure because we had that ls --al that didn't work, and I didn't take the time to go try and figure out more generally when would things work on a Mac and work or not work on a Mac involving the ---- form of the flags. Okay, so now we've got it down and we've removed the file names and we just have the lines where the library parenthesis or where library occurs. And at this point we need to start now processing through this and getting rid of cases where we're not actually loading a package. Like this one, we need to sort of convert this into 2 separate lines, or at least somehow extract out the names of the 2 packages in some form. We need to sort of get rid of this case here because this is not actually loading a package. So there are going to be lots of ways that we could do this of less or more sophistication in terms of processing this. What we're going to do here is just sort of fairly quick and dirty. Certainly, if we really wanted to do this in sort of full generality, we might actually read the result of this into Python or R and do a lot of sophisticated string processing and regular expressions. But here we're just going to try and do sort of a quick and dirty approach and see if that works. Partly just to illustrate again more of the functionality here. So what am I going to do here? Now I'm going to use a little bit of regular expressions to say only give me the cases where library occurs at the beginning of the line. So that's going to rule out this case, for example. It's going to rule out this case, for example. So the caret means library has to occur at the very beginning of the line. Okay, so now we're getting it down to more of these particular lines that I'm interested in processing through. Let me pause for questions at this point. Questions as I'm working my way through here? Okay, so another thing is I might have duplicates. In different code files, somebody might have loaded the fields package in one code file and then loaded it in another, so I want to get rid of the duplicates. So I could, for example, get rid of the duplicates with our sort and then unique that we've seen before. Okay, so that's one step here. Okay, and now what I'm going to do is I'm going to get rid of all of the cases where I've got syntax that follows a comment. So I'm going to use this in sort of an unelegant way, which is I'm actually going to use the cut command and say only give me back the stuff that occurs before a pound or a hash symbol and get rid of the stuff that occurs afterwards. So that's going to look like the following. So this says split up the results based on using the hash or pound symbol as a delimiter and just give me the first field. So this is not really a delimited file, but you can still use cut just as a trick to deal with this sort of situation. So it's going to split up, and whenever it sees a hash, it's going to treat the second part of it as the second field. It's going to treat this as the first field, and it's only going to return the first field. Okay, so if we go ahead and do that, that should have gotten rid of all those cases. That should have gotten rid of all the comment text that occurs later on in the line. Okay, and now at this point, one thing that comes in handy sometimes is this T command. So T will basically allow you to see the output of what you're doing at the command line, but also create a file out of it. So I'm having trouble cutting and pasting for some reason here.
I think it's working. You just have a new line at the end of it. So it's actually entering the command when you copy and paste it.
Oh, right, thanks. Yeah, okay. Right, so it's actually working. It's just it keeps doing it, and then it looks exactly the same. So I didn't realize it was doing it. Thanks for catching that. Appreciate that. Okay, so we can look and see if that libs.text was created. Indeed, it was. So there it is. So that was created, and libs.text should just be showing the same. Should just show us the same thing as what we saw before. So now it's in the form of a file, as well as having been printed to the screen. Okay, so that was just because sometimes I don't want to keep just adding on more and more pipes here, and in some cases we might want to split up the commands, either because that allows us to do something else, or just because so we don't have too long a line that then gets hard to interpret what's going on. Okay, so now I'm going to take the result that was in libs.text, and now actually I want to get rid of all the cases where I've got help equals as part of the line. So this V basically reverses and says, whenever you do find the pattern, don't include that line in the result and only include all of the lines that don't have this pattern in there. So now I'm trying to exclude lines instead of including lines. And then I'm going to take the result of doing that, and I'm going to output into a new file called temp2.txt using the greater than symbol. So this is redirecting. So the output from here is now what we would call standard output. I'm redirecting standard output with this operator into a file. Okay, so once I do that, if I now look at temp2.txt, I should see that I don't have any of the cases where I had library of help equals, which wasn't actually loading a package. And so I think we're basically at the end of the file. So this is basically all of the packages that we want to deal with here. Except we still have this tricky situation of I still have this case where I've got a semicolon and then a space that I want to deal with and convert that into 2 lines. Okay, so that's what this next bit where we're going to use sed is trying to deal with. So I'm going to take, sed can do a lot of things. I tend to mainly use it for just doing fairly simple replacement of either patterns or characters or sequences of characters within a file. So it's really useful for that. And the way you use it for that is basically you say, with sed, I'm going to do a replacement. So that's what the S stands for. This stands for search and replace. I'm going to look for any semicolons and I'm going to replace them with a new line. Okay, so I'm basically going to convert that case where I had 2 commands separated by a semicolon into 2 separate lines, as basically thinking of them as separate commands. I'm going to get rid of any spaces because there was still a space. After I do this, there's still a space in the result. And then I'm going to go ahead and look for and get rid of the library parenthesis using this sed statement here. And then I'm going to go ahead and get rid of all of the closing parentheses as well. And that should just isolate just the names of the packages that I then want to install. Yes, question here.
Just so I guess before, should we remove the cut to, or put before unique? Because right now we're getting like library fields multiple times listed here.
Yeah, so this is right. I didn't sort of go ahead and fully clean this up. So we would probably want to put the sort and unique sort of at the end of all this. So maybe we'll do that. Maybe we'll come back to that in a second. Yeah. Okay, so here I'm basically doing a sequence of sed operations to do the replacement that to get rid of all of the characters that I don't want, and to make sure that I convert this line into two separate lines. Okay, so questions about that? Oh, the other thing, if I guess I didn't say this, the G, so whatever we've got, so this is the thing we're looking for, this is the thing we're replacing it with. If I have a case where I don't have anything that we're replacing it with, it means just get rid of it. So we're replacing it with nothing. And if I have a G, it means replace every instance that you find in a line, whereas if you don't have a G, it just replaces the first time you find it in a line. I think for our example here, it doesn't really matter whether we're using G or not G in this particular case, but in some cases it does matter. The G just stands for a global replacement on the across the entire line. Okay, so if we go ahead and do that, and now if we look at libs.text, we can see that we've basically gotten it down to what we want, except for, looks like this guy got messed up here. So somehow or another our searching and replacing didn't quite deal with that particular case, which is funny because I didn't see that case in the original file. So, okay, it looks like our search and replace didn't work because it looked like it somehow sort of combined these lines in a way that wasn't quite correct. So let's try and see if we can figure out what's going on there. Okay, so I'm going to go back and piece apart what's going on here. Piece apart the different steps. Okay, so it looks like it replaced the semicolon with an N, which means somehow it probably wasn't dealing with the escaping of that what I wanted to be a new line character inserted into the file. So what I probably need is just another slash in here to say, in order to treat that correctly. Because basically what I'm trying to say is treat this as a new line, but then the slash n means a new line, and then the first slash in front of the slash n would mean sort of treat that literally as a new line character to put into the file. So let's see if that works instead. Okay, so hopefully that works in terms of actually, let's see. So if we do that, this worked when I first did it, so now I'm confused. The escaping is always kind of a pain, so I'm not quite sure why that's. It might be a bit different. It might be a Unix versus Mac thing because I'm pretty sure it worked on my desktop. Yeah, suggestion in the back. What's that? 3 slashes. Okay, so that illustrates the other point about escaping, which is, and this occurs in R. If you're not getting what you want, just keep adding backslashes, and you might get what you want. Okay, so 3 backslashes, and I just deleted the first forward slash, so that wouldn't work. Okay, so let's see what happens now. Okay, so libs.text, what does that look like? Oh, that didn't work either. All right. So I think, okay, so I'd have to think about this a little bit harder in terms of solving this on my Mac. We could go over and do the demo on Linux, and I'm pretty sure this would work if you did it on Linux. So like I said, this is doing live demos is a little bit dangerous for this exact reason. Let's assume that worked, just for the sake of argument, and that we didn't have the problem with this particular line here. And so if that did work, what would now happen if we did this? Huh, that's interesting. Okay, so what I'm hoping to do now is basically just, if I were doing this in the form of like a function or something I was going to use over and over again, I might want to print a message to the screen to sort of say what's going on and what I'm about to do. So that's the idea here, is saying that, okay, after I've done this processing, I'm just going to report back to the person who's invoking these commands how many packages there are that I found, and those are the ones that in some next command I would then go and try and install in R. So WC-L should say how many lines there are in that file there. And that's what happens here is we get the 22 and the libs.txt. I would have thought this, I guess what's happening here is it's not excluding, I think what's happening is it's not dealing with the white space very well. So we've got this, but it's actually just finding, when it cuts with the space as the delimiter, it's basically just cutting out in here, and so it returns a space from one of the spaces in here. Again, I'm pretty sure this worked when I was playing around with it on Unix. So I guess another lesson is I should make sure to do these, make sure to try these out on my Mac before I try and do them live. So we could do this trick of just keep increasing the number of fields that we're looking for. So 6, 7, there it is. It's in the 7th field if we split based on single spaces. Okay, so so if you're doing this quick and dirty, that would certainly be fine. If you were doing this sort of as something you might use in the future a lot or give to somebody else, you'd probably want to do this a little bit more elegantly than what we just did by trial and error. But there you go. That returns that. So we get a nice little logging message of what we're doing at this point. Okay. All right. So questions so far? Anything that I've confused people about in terms of trying to fix things live as we're going along here? Yes.
What part of this is the automation?
Why is this automating things?
Yeah.
Okay. So so let me go back to where I was trying to get to at the end of this demo, or this mission, which is then what I could then do is something like this. Oops. Where am I here? Right. I could then do something like this, which says, assuming that I had actually correctly created libs.txt, and there was that one line with where that I was messing up with the new line, but assuming that I had actually correctly created that, I could take the stuff that's in libs.txt, pass it directly into a command line version of R, and install all of those packages in one fell swoop. Okay, so that's the automation. Is instead of having to search through all the files and say, what are the packages in here, and then open up R and do install that packages fields, install that packages ggplot2, install that package whatever, this will basically do it all at once for me. Okay, so that's the automation. But thank you for making me be more explicit about where the automation was here. And this is something that will come in handy every so often is if you want to do something in R from the command line in Unix, you would generally do it by invoking rscript, and then the -e flag basically says, treat all of the rest of the stuff that's in quotations here, treat that as R commands to then run in R. And if you have multiple lines of R commands, you can use a semicolon to separate them so that you can do multiple lines of execution, all with a single line of Unix, a single line of shell code here. Okay, questions? Yes.
I'm a little confused when it wasn't working. What was the finalized one that does work?
With the WC problem or with the /n problem?
I guess what was trying to be accomplished with the /n?
Okay, so what I was trying to do with the /n was take, so let's say I think temp2.txt was the input here. I was trying to take this and basically insert a new line right in here in place of the semicolon. I'm pretty sure that on my Linux machine that worked by just saying insert a /n, which is the sort of the sequence of characters that stands for a new line in terms of an ASCII file. But for some reason it didn't quite work on my Mac here, and so I'll have to go back and figure out why that wasn't working. But that was the idea of what I was trying to do there. Okay, other questions? Yes.
I think we could translate the semicolon to a new line using the TR command.
Oh, with the TR command? Okay, that might work. I'm actually not all that familiar with TR, but if we do man of TR, so it says it translate characters, it says it copies standard input to standard output with substitution or deletion of selected characters. So that would be an interesting one to try, and I suspect, given it sounds like you've done this before, that would work in this case. Okay, other questions or comments? Okay, so let's go on to the last example. And this one gets a little bit into controlling jobs on a Unix machine, which I said you didn't have to look at too much when you were looking at the bash tutorial. But it also illustrates a few other things as well. So where are we here? So our fifth mission, So this is the sort of thing that comes up if you have a project where you're trying to run a whole bunch of computational jobs. You might have, from the command line or in some other way, started up 30 or 40 different jobs. Maybe there are jobs, maybe they're Python jobs, maybe they're particular binaries that you're running. And so you might have started up a whole bunch of jobs and then realized, oh, I made a mistake. I shouldn't have started up all those jobs because I had the wrong input to every single one of those jobs. I want to go back and kill off all of those jobs. So if you're in the shell, you can usually do something like, if you look in top, which will tell you what's running, you can look up the process ID of the jobs that are running. So here are the process IDs for these various jobs, and then you can do something like kill and the process ID. So if there were process 3434, I can do kill 3434, and that will then kill that job. So the idea is, what if you had 30 jobs that you wanted to kill all at once? How would you go figure out what would the process IDs of those 30 jobs, and then automate the process of killing them, so you don't have to sit here for 25 minutes typing in the names of all of the job IDs that you want to kill. Okay, so the idea here is this code here is just a precursor to then getting to the point of the mission. So this is my syntax that I'm going to use to actually start up these jobs. So obviously you would not usually start up a job that didn't do anything, but that's what I'm doing here. Is I'm saying create an R code file that all it does is sit there and sleep for 100,000 seconds. Okay, so these are going to be very long jobs that do nothing. And I'm going to go ahead and start up 30 duplicates of that same job, just so that I have some jobs that are running that I can then go ahead and kill. Okay, so part of that was just to illustrate that you could actually automate starting up jobs. And the other thing is it just illustrates the syntax of a for loop, which you guys saw in the tutorial that you were looking at. Okay, so we're looping from I in 1 up through 30 until we get to I at least 30. And then I++, this is like C++ style indexing. That's going to index the variable I in here. Okay, so we're going to start up a whole bunch of jobs. Okay, so now I have 30 jobs running, all of which seem to have a process ID that start with 9.1 and then something, something, something. If I did top, it does actually show them here. So it shows I've got all these R jobs running. Not surprisingly, they're using 0% of CPU because they're not actually doing anything. Right? They're just sitting there, wasting time. Okay, so now let's suppose that I want to go ahead and kill those jobs. Well, first off, we need to know how to query and look for particular kinds of jobs. So that's what's in that we can do with this ps command. So let's go ahead and, oops, where am I here? All right, I seem to be having trouble copying and pasting today. Oh, there it is. I guess it was just delayed. Okay, so PS will take a -O flag, and basically, if you just do PS, you get a whole bunch of information, and it doesn't give you a lot of control over what columns of information are returned, which are in terms of which ones you want. So these are some of the names of columns that I'm particularly interested in. All right, it looks like maybe the -C doesn't exist on my term on the Mac here. Okay, so this gives me the process IDs of the CPU usage, the memory usage, and the user, and then it should be showing the command as well, but for some reason it seems not to. So again, I think this is a Linux versus Mac thing. Let me actually go over to my Linux workstation, because I'm afraid some of the rest of that won't work either if I don't do it there. So rather than having more issues in terms of differences, it's a little bit frustrating because we're running a bash shell on the Mac, so I'd really like it if things were really more similar between doing it in Linux and doing it on the Mac, but I guess that's the way things are. Okay, so here we go. Okay, so this, did I start the jobs? No, I didn't. Oh, I did. Okay, so, okay, it took a little while for all the jobs to start, but now they're all running. Okay, so now what I've done is I've listed out all of the jobs with their with the information I'm interested in, CPU, memory, user, username, and the command. But now what's happening is I've got these 30 jobs that I started that I want to kill, but I have some other R jobs that I'm probably running on my workstation that I don't necessarily want to kill. So I just want to kill the last 30 that I just started, which are the most recent ones. So now that would be that I could do that by sorting correctly based on the start time of the jobs. And then I'm going to look only for R jobs, so jobs that are actually running the R executable, so that's what the -C does. And now I'm going to say only give me back the last 30. So that should tell me what those last 30 are, and I can check indeed those are the ones that started at 2:51, which are the ones that just started in the last minute or so. So I've now sort of isolated it down to the 30 jobs that I definitely want to kill. And now at this point I really only need the process ID, because that's the information that I want to pass in to kill, to be able to kill the jobs. All of the rest of this stuff in each of these lines, all of this stuff here is just extraneous. I don't need that information. I was just printing that out to make sure that I was finding the jobs that were the ones that I did actually want to kill. So at this point all I need to do is just get the process ID and not all of the other fields. Sort it, only the R commands, only the last 30, and now I'm going to use that convenient xargs command to then pass those process IDs in as the arguments to the kill command, and so that I can kill those particular processes. Okay, so if I go ahead and do that, you can see it gives me back information that indicates that all of those jobs exited because of the fact that I went in and I killed them off. Okay, so a little bit of illustration of a for loop, of using PS to find jobs of interest. Another illustration of using xargs, because we need to pass in arguments and not standard input to the kill command. And I guess those were the main things there. Okay, so questions or comments? Okay, so let's switch over and have you guys take a few minutes and start working on the first of the problems that I pose in the unit. So this is in the bash unit. And this is going to be what we're focused on for class on Wednesday, is having you guys work together and then talking through different solutions that people came up with in class on Wednesday. Okay, so the first challenge for you guys to think about and work on for the next few minutes is, suppose that I wanted to write this output out to the screen, where the 2 was programmatically determined based on looking for the word bash in this particular file. How would I go about doing that? So take a few minutes, confer with your neighbors, see if you can come up with syntax that would do that, and then we'll chat about that. Are there any assignments that I did not get from people? Oh, no, your name. All right, so what command do I need to search for bash? Grep, okay. Flags that people were using? So if I just do bash, what file was it? Was it unit2-bash.sh? Okay, so that would, so now what do I do?
Pipe it to word count.
Okay, so I could pipe it to word count. Do I need a particular flag?
Use -l.
Okay. So that works in this case. When would that not work? Yeah, if a given line had bash in it 2 times, so if this said, you know, bash shell examples, blah, 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 bash, we'd only see 2 lines, but there are 3 occurrences of the word. Right? So that would foil our correct counting. Any thoughts on how we could deal with that? So if we do man of grep, there's a -o flag, I think. So this only prints the matching parts of the lines. So that should, I think if we had a file like the, right? So just, you know, if you need to, just create a test file that you can do these things on. So grep the in temp.txt, grep -o. Okay, so that returned every occurrence of the in the file, and now the word count -l would still work because it nicely spaced each of the occurrences out onto a different line. Right? Okay, so that worked in that case.
Also use -c to count.
Right, so another flag we could use, which I think I haven't mentioned as much as I might have, in part because somehow it's just not ingrained in my memory, is you can use the grep -c. So what if we did grep -c here? Does that actually work? So that is only counting, it looks like that's only counting lines, but what if we did grep -c -o? Would that work? No, okay. So we need to think a little bit more about this to see how could we combine these things together correctly. Okay, and then the last thing, how do we get it into a text string? Okay, so we could do something like echo, and I'm not going to write it out because I don't remember what I exactly said, but something, 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 and then $, and then whatever we did, whatever it was that we just did, right? So, and then the parenthesis. Okay, so that didn't quite work to solve this exact problem, but you can see that would solve the that should solve the problem in general. Although it did unfortunately introduce a whole bunch of extra white space, and we could still do a little bit of work to get this cleaned up. Okay, but in any event, we're out of time. Okay, so we'll come back and work through those other challenges on Wednesday. Remember, we have section today. We're going to be talking about Git and about turning in problem sets and about formatting problem sets. And the first section, the 3 o'clock section, probably won't start till about 3:15, just to give me time to clean up and get up there and get set up. So.
This is my definitely